All right, so I'm guessing I'm going to kick it off and hand it over to you, David, in a minute from now. Hello and welcome everyone to this Meet the Experts webinar on how to get started on scripting in Max Interactive. Today we are very happy to have David here from Montreal. He's a product owner at Autodesk. He's going to introduce himself in a minute. I just wanted to introduce myself as well. So my name is Alex. I'm a product specialist on the 3ds Max product family based out of Europe. If there are any questions in the long run, please feel free to use the chat, make yourself familiar with the kind of the layout in the Zoom webinar. Just be aware, for those who have just joined, by default, you're sending the chat messages only to us, to the panelists, but you can change that to be readable by all panelists and attendees at the same time, which is great because other people will see your questions and might be able to answer one or two of those. The full webinar is going to be recorded and placed online by the end of the week. Everyone is going to receive an email, a post, or past the webinar, or I guess also at the end of the week, pointing you to the download or to the to the video, to the recording. That said, I guess I'm going to mute myself and hand it over to you, David. Thank you very much.
Great, thanks, Alex. So I'm David Menard. I'm product owner in Montreal for Autodesk Live. So we use Stingray or Max Interactive a lot, extensively in our product. My background is in engineering. I've been at Autodesk for about 4 years now. And professionally, I was scripting when I was working in video games, but ever since I transitioned to product owner, I kind of stopped scripting professionally, but I do have a lot of questions when it comes to using Max Interactive and scripting. So I always kind of at least dabbled into it. And this class, we've been doing it a few times now, and there's been a few cases, at least internally, where our QA or our artists wanted to start scripting. So I put this class together and it was really a big success. We've had a few people who really didn't know anything about scripting, who never even wrote a little line of code, that really got into it and started writing whole projects, entire projects. So after that, we gave this class a few times, once at AU, once another time internally, and it was really a good success. So I loved giving this, and we've done it a few times already. So before we get started, for everyone who wants to follow along, go ahead and download the handout that I just posted the link to in the chat. This is going to be up after the webinar too, if you want to download it later on. But also open the project manager, open Max Interactive, of course, and open the project manager and create a new empty project. So you go in templates over here and just create a basic template. No need to do anything fancy, just so that it gives the time to compile and that we can get started as soon as we're ready. So the interesting thing about this class or this webinar is I try and rehearse it as little as possible. The reason is that when you're scripting, you're always going to make mistakes no matter what you do. It's kind of just how scripting goes. Either you make a typo, either you make a logical mistake, something doesn't compile, it crashes. And my intention is to make mistakes while doing this webinar, so that you can see the entire process of not only writing scripts, but also debugging it, which is pretty much half of what you're going to be doing. There are a couple polls as well. I saw that, Alex, you started the poll. If anyone wants to follow along or listen in, it'll give me kind of the sense of how fast I should go. If everyone wants to follow along, well, I'll go a lot slower than if everyone wants to just listen in and practice at home later on. And Alex, did you send the first poll as well on?
Not yet. Not
okay,
yet. Let me.
Great. We'll send it after this one.
That's great.
All right. As far as the handout goes, the handout will go a lot further than what we do today. So we're gonna cover a few basic elements of scripting, and these concepts that we're going to cover are usually good for scripting in general. So we're going to script in a language called Lua. Very simple, very straightforward, but the basic concepts are good all around. We often say that once you know one scripting language or one programming language, it's really easy to transition to anywhere else. So what we're going to learn in Lua, variables, functions, also apply to, you know, C# in Unity or Blueprint, C++ in Unreal. They're good all around. They're good for Python as well if you're using, say, 3ds Max or Maya or anything else like that. So good stuff. All right, so seems like everyone wants to mostly listen in. That means that I can go a bit faster. This is good. It's recorded, so you can always come back to it. For those of you who want to follow along, it is a minority of people, so if you have any questions, just post in chat, and me or Alex will try and help as much as we can. All right, so for the second question, have you scripted before? So a few people can manage. A lot of people, it's their first time, so good. This, by the way, is really designed for a first-time scripter, so we're going to start by the very, very basics. So it seems very, at least very well distributed. There's a couple people who say that they're scripting gods. Maybe you guys can help in the chat. I'm certainly not a scripting god. All right, excellent. So let's get right to it. So now that you have your project open, so the poll is fine. I just wanted to get a nice distribution. We can close it. All right. Now that we have our project open, you have the basic structure, right? We have content where, you know, you have all the units, you have all the geometry. What we're interested in is the script folder here. If this is a bit too small, by the way, I can't really change it, but we'll minimize our interactions here. In the script/Lua folder, there's one file called project.lua. If you double click on it, you'll open the script editor. Now, this is a first pro tip. I actually don't really like this script editor that much because, first of all, I can't zoom in. Also, the debugging functions in it are not that great. I really like using the external console. So if I go in Windows, there's an external console here, Alt-2 is the shortcut. If I click on this, where's my external console? It's over here. You'll see this is basically the same thing as the log console down here, except it's a bit more focused. There's also in the Lua menu a debugger here. I usually use that because the script is really a lot more complete, a lot more accessible. And I can zoom in to actually do this and show you guys what I'm writing. So go ahead and do this. It's Windows, external console. Once the external console is open, Lua, and open debugger right here. From there, I'm going to open the file that I mentioned, project.lua, so I can start writing project, and you'll see that script Lua project is right there. Yeah, I'll try and change the screen resolution to zoom in a bit. I'm going to have to stop sharing to actually do this. I'm going to reshare in just a second. All right. So let me share again. So now everything's at 150%. I'm guessing this is much better.
Yeah, it looks good.
Okay, excellent. So this is our project.lua file. It's kind of our entry point for everything that's scripting in 3ds Max Interactive. And don't be too intimidated by this. We really have just one little line that we want to add here. There's a line at line 32 called function project.onLevelLoad preflow. So everything that happens in here will happen before the level, right after the level loads, and right before the first flow node is called. So there's a flow node called like on-level load, that this actually happens before that. So I'm going to add one line. Our first line of code is right here. At line 35, I'm going to write print and hello world. Oops, like this. And I'm going to save. So for those of you following along, I'm just going to leave this hanging here for a second. Is the text big enough, by the way? You can read this properly? Excellent. All right. So now that we wrote our first little line, I'm going to press on play game or run project here. Once this starts, you'll see that in the log console, there's a little hello world that showed up here. And same thing in my external console, there's hello world right here. So that's it. That's the extent of scripting. We're done. Pretty much, scripting is very simple. It executes, the project will execute line by line exactly. And when I mean exactly, I mean very precisely every single line of command that we write it. And the first thing we tell it to do is to print hello world in the console. So this is exactly what happened. It printed a hello world, and this is our first line of code ever. So now the thing that's important to note is that eventually your programs can get pretty big, can get pretty intricate, you know, this calling that, this calling that. But whenever there's a bug, there's never ever anything magical happening. It's really just executing line by line. So whenever there's a bug, it's because we screwed up. It's always the programmer who pretty much screwed up. If it's washed out, I think it's because I optimized the streaming for interaction, so it's going to clear up a bit in just a second. All right, so printing hello world is nice, but what we really want to do in Max Interactive is interact with the engine itself, right? We want to be able to move stuff around, spawn new units, click somewhere, and all of that is going to be done through an API. So API stands for Application Programming Interface. And when you're working with a game engine, your best friend all the time is the documentation. In the handout, there's a link to the documentation, but if you want to find it, you go into Help. And right here, there's documentation, or you just press F1. This brings you to the Stingray Learning Center. So there is, on the left side here, there's a big panel with a lot of stuff. What interests us when we're actually coding or scripting is a Lua Api reference right here. I'm going to go ahead and click on this. This contains every single call you can make to the engine. So everything you can do to interact with Stingray or Max Interactive. By the way, I'm going to use Max Interactive and Stingray interchangeably within this presentation. Whenever I say one, I mean the other. Don't worry. So whatever you can do to interact with Stingray is in this documentation, and I mean all of it, and there's a lot of it. So the quick find feature here is really useful. What I want to do first is spawn a unit, right? We have this little cube in the center of our scene. I'm going to move it just to be a bit more practical here. So I'm going to move it over there. And what we're going to do now is ask the engine to spawn a cube right in the center of our scene right here. And we're going to spawn the same cube. So let's go back to our script. Right under hello world, I'm going to call our first function to the engine. So what I want to do is to spawn a unit. So I'm going to go back in my documentation and start writing spawn something something. You see that right away you can see everything that's available to spawn units. What I really want to do is spawn unit. So I'm going to keep typing like this. And there's stingray.world.spawn unit. This is what we're looking for. So this will give us the details of how to use this, this function. This is called the function, and we'll get back to what functions are. So I'm going to go ahead and write exactly what I found. So this was under world. This means that to call this, I'm going to go Stingray. Stingray. So every time you interact with the engine, we start with Stingray. Then we found this in world. So I'm going to write exactly this, stingray.world. And then you call the function .spawn unit. So spawn unit. Now, these parameters that you see here, the self, unit name, position, orientation, this is what the function needs to be able to work properly. So the first one is called self. It says that it's a Stingray world. So we have to give it a world. In the project, it's pretty straightforward. There's something called the app kit that kind of manages the world for us. So I know from experience that the world, I can access it like this, appkit.manageworld.world. This is kind of standard in the Stingray templates. For now, just take it for cash that this is how you get the current world. The reason that this exists is that Stingray actually gives you a lot of flexibility on how you can manage the worlds. So you can overwrite this if you want, but this is really kind of the easy standard way to do this. So that's for the first parameter, the world. Next, we're seeing that it takes a unit name, and it's a string. So a string is just a series of characters. So unit name is the name of the unit to spawn. We need to give it the entire path of the unit. So I'm just going to do this, and I'm going to go see where my unit is. So I'm going to right-click on my unit in the viewport and click on Find Selected Asset in Browser. And now if I look at the hierarchy, I see it's in Content, Models, Props, and it's called Champ Box. So I'm going to write that entire path, right? Content / models / props / champ box, right? Okay, good. And I'm going to save right now. I usually always spam Control S, by the way, and this is normal. There's a compile error. So my script didn't compile. That's because my line is unfinished. I left this open here. Now I opened a parentheses here, but I never closed it. So Stingray detects that right away and says, hey, at line 30 something, or at line 35 here, you have an error. So it tells me I have an error. It doesn't necessarily tell me what. You can read the message. Sometimes it says exactly what it is. So parentheses expected, close to at line 35. So at least now it tells us pretty much exactly what the error is. So I'll go back to my documentation. And next, the spawn unit takes a position and orientation. And the documentation, what's great is that every time there's a question mark here, it means that these parameters are optional, and it also says it right there. So you can give it a position if you want to spawn it at a specific location, and same thing, you can give it a rotation, but these are optional. So if I don't give it a position or rotation, it's just going to spawn it at 0, 0, 0, and it's going to give it a rotation of 0, 0, 0 as well. So I'm going to leave it that way. I'm just going to close my parentheses, and I'm going to click on play. So there you go. My cube is spawned at 0, 0, 0, and you can see that it's even, the scale is normal as well. It's 1, 1, 1. It means that my other cube over there on the left side is even scaled down. So this is kind of the basic things that you need to know when interacting with Stingray. So we did a few things here, actually. We called a function. We called a Stingray API. And now we need to kind of know, what all of these things are that we did. So the first thing I want to go through is what a variable is. Those of you who already scripted are pretty familiar with what a variable is. A variable is just a container that you can put pretty much anything in it. The way you declare a variable is with the keyword local, and this changes from language to language. It can be local. Sometimes in C# you need to declare the type. So string, integer, Boolean, that kind of thing. In Lua, it's really easy. Every time you call local something, it means there's a variable there. The variable, you can give it any name that you want. So I'm going to call it my variable, or here, my box. And I'm going to assign it to nil. In Lua, nil just means nothing. So now my box has nothing in it, but there's an empty container here. So I can put something in it. And the function spawn unit that we looked at earlier actually returns something. So if I go down a tiny bit, you can see there's a return type, and it says stingray.unit. The stingray.unit is a specific type associated to Stingray. It's the Stingray unit. So this means that whenever I call this, I can assign it to a variable and use it later on. So if I do something like this, I cut this line and replace my nil for the unit, or for this function call. This function call will return a unit, and the equal sign here is actually a way to assign things when programming. It's not, you're not comparing, you're not saying that this is equal, you're assigning it. So we're putting the spawn unit, I can draw here. You're actually putting the unit inside the container that is my box. This is useful for many reasons. The main reason is that you can later on use my box. How do I erase this now? Yeah, there we go. The reason is that you can later use my box to do something else, say change its position or make it go further and further to the left. And let's actually do that. So same thing, now that we have a unit, I'm going to go in the reference in the documentation and look at the unit reference right here. Yes, capitals are important. And so the question is, are capital important? Yes, they are very important. So are underscores. You can't write something like my box here. This just won't work. Capitals are very important. Most programming languages will be cap sensitive. All right, so let's go into unit, and under unit, there's something with, actually I'm gonna search for it. There's something called local position, right? Unit.local position. So this says retrieves the local position of a node in the unit. Okay, fair enough. So I'm gonna call this to see what happens. So I'm gonna go Stingray, and this time we're under unit right here. So I'm going to go stingray.unit, and the function was called local position. So I'm going to type this, local position. Going to look at my API. Once again, it says self, so specifies the object instance that this function will act on. This means I can give it a unit. So I'm going to give it my box. I'm just going to copy paste. I copy paste a lot when programming. And the next parameter is the index of the node. So the node, I know that this box actually only has one node. If I open it in the unit editor, you're going to be able to see that this actually only has one node. This isn't too important. I'm just going to say 1. So it's the first node. So local position, great. I have this. I'm going to look at my documentation, and it returns a Stingray vector 3, the position of the node. So I'm going to create another variable called local my box position, and I'm going to assign it here. So this takes the local position of my box, puts it in my box position, and then I'm going to print it out just to make sure that this actually works, right? There we go. So I'm going to save this. I'm just going to leave it up for a second for those who are trying to follow. So to recap, we're taking the world, we're asking it to spawn a unit, the unit that we're giving it a full path. So we're spawning a box. We're taking that box, grabbing its position, putting it in this variable called myBoxPosition, and then we're printing myBoxPosition. So the result of all of this should be in the console, we're going to see hello world. Then we're going to see nothing in the console here, but this is going to add a box to my world. And then in the console, we should see the position of the box that we spawned, which is 000 because we asked it. So this is the expected behavior, at least. I'm going to show my log console, and I'm going to press on play here. Okay, so there's my box, and this all happened way too fast for me to actually see anything happen, but there's hello world, and here is the position of my box. So this can get confusing whenever the console, whenever you're looking for stuff in the console, because there is a lot of messages here. So if you want to make it a bit more explicit, you can just print something like position, all caps, so that it stands out. And in Lua, to concatenate strings or to add them together, you just go ... So this will say position and then add position. If you want to make it even more obvious, you can do something like this. So now, if I rerun the game, it's going to be pretty. Oh, there we go. I have an error. Excellent. So it says attempt to concatenate local myBoxPosition a user value. Okay, that's normal. The reason is because we're trying to concatenate a string with a vector. All right, and that cannot be done. So we're going to actually print it 3 times. These errors can be very intimidating. I'll get right back to it. So I'm going to just print the X position instead. Okay. And there we go. We have another error. Or I just didn't restart it properly. All right. I didn't save. Remember to save, people. It's important. And there we go. Now we have position X 0. So let's get back to this error. The error says script Lua project Lua and 38. This means there's an error at line 38. In this case, it's very obvious that line 38 is where we're printing. So there's an error somewhere on this line. Sometimes the error won't necessarily happen on the line that it's actually happening, or it won't report that it's happening at the right place. When that happens, you actually have something called a call stack here that's really useful. This will tell you everything that was called right before the line where there's an error. And the rest of the line here of the error will give you a bit more detail on what the error is. Usually these are pretty generic though. So you have to start interpreting these errors and making sense of them. It takes some time. You'll see that the first time you get an error, you're probably going to spend 15 to 20 minutes trying to figure out what it actually means. But there's a limited number of these errors that actually happen. So once you're used to it, after a couple days of programming, you just plow through these pretty fast or pretty quickly, and these start making sense to you. So this is just a matter of experience. All right. So last time I did this, a lot of people thought it would be a good idea to jump into custom flow nodes a bit quickly. So that's what we're going to do right now. Flow nodes are, for you, those of you who are not familiar, flow nodes are kind of a visual programming language. So if you go in level flow, up here, you're going to be able to, add some visual nodes here, and everything can be very customized. So if I take level loaded, click in here, I can say, okay, print hello world from flow. And And if I save this and run, you're going to see that in the console, something's actually going to be printed. And remember when I said that our function here was called before the first node of flow? Well, the hello world is being called, our unit is being spawned, and after that, we're going to see hello world from flow. So what's useful in flow is that you can write your own nodes, and they can be customized to do pretty much whatever you like. The reason behind this is that you can create complex behaviors in a single node that are really, really useful. The second reason that you want to write flow nodes is because the number of flow nodes are actually pretty limited here compared to the Stingray API that has a lot of stuff in here. So there's a lot of these function calls in Stingray that are not exposed in flow. And I'll give you the first example is open URL from browser. So this function is super useful. It's super simple, but it does not exist in flow. So we're going to write that node in flow and give you an example of that. So the way you write flow nodes, you actually need to have a file called with the .flownodes extension. So if I right click on here and open the file explorer, you're going to see there's a global.scriptflownodes file, conveniently enough. And you can write as many as you want in here. If I open this, you're going to see that it's not quite Lua. It's what we call JSON. It's just a way of formatting things. Most of everything in Stingray behind the scenes is actually JSON format. So I'm going to copy paste this node. And whenever I create flow nodes, by the way, I go into the documentation. Let me get back to home, and I enter keyword. I search for custom flow nodes, press enter, and I always go into this link, the creating custom flow nodes link right here, and I just follow this. This is how I learned to create flow nodes. There's no magic to it. I just read this page and practiced. All the information you need is really in this page. So this is pretty straightforward. The name of the flow node, I'm going to call it open URL from browser. The args are actually the arguments or the parameters that we're going to give the flow nodes. They're very similar to when we had our function calls from our API. So let's go back to local position. They're very, very similar to these arguments here, to these parameters. So arguments, I'm going to give it a URL, and it's going to be a string. And the function is what function is going to be called whenever this flow node is called. So I'm going to call the function URL, open URL from browser. And the category is going to be project. The category is actually where the flow node is going to show up when you right click. If I put it in project, I'm going to save this, by the way. If I put it in project, that means that it's going to be in project under here. And there you go, open URL from browser. And I'm going to say whenever I hit the keyboard button, my mouse is lagging a bit. Whenever I hit the keyboard button called space, so whenever I hit the space bar, I am going to call this flow node. And I'm going to open the URL called Google. And I'm going to save this. Now, I created the flow node, but I didn't create the function that's going to be called. So this will probably give me a big fat juicy error when I press spacebar, because obviously there's nothing to do. We didn't define anything that the flow node would do. So if I press spacebar, there we go. We have an error called function not found. I'm going to open it in here so it's a bit bigger. Function not found, project flow callback. So it's normal. We didn't actually create this function. All right, fair enough. Let's go create that function. So by default, the script flow nodes for the project are going to be in a file called script flow node. Let's just search for flow nodes. flow callbacks, I think. Yeah, there we go. So in script Lua flow callbacks, I'm going to open this file. You're going to see we already have an example for an example node. If you remember our global.script flow nodes file right here, there was an example that I just copy pasted. We're going to do the same thing in this script file. So I'm going to take this function and I'm going to copy paste it. So a function is just a series of commands that I can call, or I can bundle together and call repeatedly. So if I want to spawn a unit and at a specific position, I can create a function to spawn a unit at a specific position. In this case, I'm going to create a function that's called every time that my flow node is called. So I said here that I'm going to call it project flow callbacks.open URL from browser. So I'm going to open this and I'm going to call it exactly that. Open URL from browser. Yay. And just to make sure that this is being called properly, it's not going to do anything yet, but hello from inside my custom flow node. So best practice when you're programming, you write one line of code and you execute. As you run the game as much as you can. The more code you write without testing, the crappier your life will be when debugging. So I didn't actually do anything in this node except for printing. The reason I'm going to run this is just to make sure that, you know, everything is fine. And believe me, you want to do this as much as you can. So if I press spacebar, this function will be called and we're going to print something to the console. So I'm going to open the console right here. I'm going to press spacebar a few times, and you see that every time I press spacebar, it says hello from inside my custom flow node. Great, so this was working. Now I don't actually want to print when I press spacebar. I want to open the URL from my browser. So I'm going to go back here in my documentation. I'm going to search for open URL in browser. And when I search, by the way, you can see that there's a how you call the function right here, stingray.application.openURL for browser. So I'm going to do exactly that, stingray.application.openURL from browser. And remember that when we defined our flow nodes, we said there was an argument here called URL. We're going to take this argument, and they're actually passed through a table. I didn't go through what tables were, but they're containers of multiple variables, and they're all inside T. So if I wanted to access my URL here, all I have to do is say t.url. Say, for example, we gave another argument here that would be another URL. For some reason, we could do something like this. Well, the way we would call this, or we would reference this here, would be t.another URL. It's that easy, and you can really name them whatever you want. It's up to you. Right. So now this, whenever the flow node is called, should be able to open the URL from browser. This is what I expected to do. It's going to open my default browser. I have a typo in application. Excellent. I'm going to leave it there so that you can see what happens, because obviously I wouldn't have noticed the typo in application. So if I press spacebar, it's going to give me a big red error. I'm going to look at what my error is. It says at line 12, I have an error. So line 12 is here. So I have an error somewhere in this line. Great. Next, it says attempt to index field application. So this is what I meant when these can be a bit not too precise. It's not telling me I have a typo, obviously. The application doesn't know I have a typo. The only thing it tells me is that application is a nil value. So there might be a few reasons why that is. I might not have defined application, but in this case, it's because I have a typo. So applicatin doesn't actually exist. So no, obviously it's a nil value. Remember, nil is just nothing. So application, gonna add my O. And now this should work. I'm going to press spacebar, and once again, I have an error. Maybe I didn't save. So attempt to call field open URL from browser. So I might have a typo there as well. Open, I don't think so. I'm going to look at, oh, it's not open URL from browser, it's open URL in browser. There we go. So once again, I misread this. I'm going to save, and I'm going to write this, and this should work. Third time's a charm. Once again, I have a red error. Okay, this time it's a different one. It says URL must use HTTP or HTTPS protocol. So that's a simple one. If I go in level flow, remember I gave it www.google.com. I'm just going to give it http//. Yeah, you can copy paste from the documentation. I know there's a little hand saying that you can click on it, but no problem, you can copy paste. And I usually do, honestly. And now that I added HTTPS or http.google.com, fourth time's a charm. If I press on spacebar, now it opens a browser. Cool. So this is working. And this is how you create your first flow node. Now, this might not seem like much, but honestly, from here, if you know these basic steps, you can do a lot from here. Most of the entire, I don't know if you tried the VR Museum template, but most of it was made in this fashion. All the flow nodes that are written by default, by the way, that are available are all written in this exact way. And now you have the entire power of Stingray at your disposal once you know how to do this. Because these flow nodes can become as complex as you want. You can do pretty much anything from here. So I'm going to let that sink in and take a few questions if there are any. If there aren't any questions, you know, we only have 15 minutes left. So we will go into Q&A soon, but I want to go through, let's say, tables. I get URL must something. Oh, when is the best time to use flow nodes? That's a tricky question. Okay, flow nodes are a great way when you're collaborating with artists or game designers, or someone who doesn't necessarily know how to script. That means you can create a very complex flow node and give it to someone else, and they can use it independently. It's a great way as well to organize your project. The project, if you keep writing in Lua, your files can get very, very big. If you want to compartmentize, if you want to be able to chunk your code into more manageable sizes, you can use a flow node to do a certain task, then link it to another task, then link it to another task. They're really great for keyboard shortcuts when you want to do a specific action on a specific key press. This is pretty much the best way of doing it. I always use flow nodes for these use cases. Okay, so we're going to go through the perfhud artist. I think this is a good idea. Any documentation on how to connect to a MySQL database? There is no documentation that I know of about connecting to a specific SQL database. You can use SQLite, which has a C++ interface. There are WebSockets in Lua that you can use to connect to to a SQL database. But I haven't seen an example of it documented anywhere. I know it's been done though. Okay. So the perfhud, this is a good place to start. It's not strictly It's not strictly related to programming or scripting, but the perf HUD is a good place to get more info. So let's say you have a huge scene with millions and millions of polygons and it's not running smoothly because you're trying to go in VR and you're trying to reach a lot of frames per second. Well, the perf HUD is a great place to start. Under View, Performance HUD, the artist performance will give you a lot of information on, on what's happening in your scene and how to best optimize it. So it gives you the time that that the application takes to render things around. So you have the number of primitives here, which is the number of polygons. You have the number of batches, which is just the times you call the graphic card to actually draw something. And you have your FPS. Now inside the editor, your FPS is capped, so it's limited artificially. But once you run the game, you can show the perf HUD and you'll see that the FPS won't be capped artificially. So the way you run the perf HUD inside the game, by the way, is that you open your external console and you simply write perf HUD artist, just like this. This sends commands to the game. So if I click on enter here, I sent this command to the game, and you'll see that my FPS is at 400 and something. It's really, really fast. So this is the best way to debug your performances, at least. So now you see I'm still at like 400 and something FPS. If I start copy pasting these boxes everywhere, eventually it'll drop, but I'm gonna have to have a lot of boxes to do that. I can try and make it drop a bit. Okay, more questions. How to control actor in Scaleform from Lua and how to connect with Stingray. Okay, so Scaleform has its own documentation. If you look into the documentation, there are two namespaces, Stingray and Scaleform. This is pretty much your reference to Scaleform. The way you ask Scaleform to do something and you reply back is through send message here. There are actually some great examples of this in the sample projects. If you go into, by the way, when you're scripting, everything is learned by example. So if you go in main menu, I'll actually open it in my external console. The main menu script has a great example of how you send messages to Scaleform. So you can see you can connect to custom events, and whenever you click on stuff, you just send messages. On that, I'm going to go through tables real quick. So tables are just a series of different variables set together. The way you declare a table is like this with squiggly brackets. I'm going to write it my table. So they're really just a series of variables. They're really useful because they can scale forever. You can have 1 million elements in my table and just scale it. So if you want to spawn 1,000 units, well, you're usually going to use a table. And you can add to my table. You can add variables by just doing a dot notation here. So my name, and you can continue adding things like this. My table dot my last name, you know, like this, and this can go on forever. Now I'm also going to show you the debugger because it's very useful. If I click on the margin here, you're going to see a red dot appear. So now if I press on play, press on spacebar, okay, the breakpoint did not get hit. Usually the execution will stop here. The reason the breakpoint did not get hit is because you're going to see a few tabs here. It means that every time I run Stingray, there's a different tab that's going to appear. I simply didn't start the debugger on the right tab, so I'm going to close it and open the debugger on the correct tab. Press on play again. The way you know that you're on the right tab is because things actually appear in the console. So now I'm going to press on spacebar. And it still did not. Was I not on the right tab? Yeah, I was not on the right tab again. Okay. There we go. So now hopefully it actually does get hit. Still nothing. Oh, yes, okay. It did it opened the URL and you'll see that now my game is frozen, right? Nothing is happening. That's because I hit a breakpoint. The breakpoint is really useful to, first of all, see what's happening line by line. Second, you can actually, you can inspect your variables when you breakpoint. So I can see whatever is in T. I have a URL and it's called google.com. Now that I have my table, by the way, my table is not good because I didn't write local in front of it. That's why it wasn't showing up. So I'm just going to do this again. Okay, my breakpoint is hit again, and you can see that my table is actually going to appear here. Now, after the line 14, my table is empty, right? If I press F10 or step over here, it's F10 is the shortcut. It executes line by line, essentially. As soon as I add my name to my table, I can see that it's added to it here, and I can inspect what's in the table. If I execute one more line, you'll see that my table now has 2 elements in it. So this is extremely powerful when debugging, because sometimes your tables get so big that you lose track of what are in them. Sometimes it's very abstract because you're working with variables everywhere. This is really a really concrete way of getting some information about what is actually happening. So debugging like this is really, really useful, especially when you're getting wonky errors that you don't necessarily know what the meaning is. Great to give you some good insights on what's actually happening. So I'm going to stop here because we have about 5 minutes left. Like I said, the documentation, the handout that I use, goes a lot further than this. There's the intro, the hello world that we did. We went quickly through spawning a unit and using the Stingray API. We went quickly through variables. We didn't go through comments, so I'll let you read that. We saw what a function was. We skimmed barely through tables, so there's a better detailed information or a detailed explanation of what tables are in here and how to use them. There's also writing a custom flow nodes that we went through. And after that, it goes really, really deep into some other things. If you finish this handout and you understand everything there is in there, you're pretty much good to go to script pretty much anything at that point. So I encourage you to try it out. It's not that long. It'll maybe take you few hours, 3-4 hours to go through the entire thing. The real important part when scripting is really just practice. It's interpreting those bugs, is realizing that humans are essentially very stupid and will make very stupid mistakes when programming, and that on the flip side, the computer is very stupid and will do exactly what you tell it to do, no more and no less. So once you come to that realization, you kind of get into the groove of it and you can get some results really, really quickly. Again, this has been done by a few people that are really non-programmers at their core, and it's been very, very successful. Okay, once the game run, can you go to the console? Yes, once the game is run, you can still open the external console after the game runs. You'll just see more tabs appearing here. Just make sure that you have the right tab selected. The level editing viewport behavior tab is the editor here. Data compiler, because it runs one tab per instance of the engine. So there's one tab for run game and there's one tab for test level. So just make sure you have the right tab selected. How do I get the documentation? There's the handout that Alex just sent out, or the Stingray documentation, you just go through help and documentation up here. Any other questions? Okay, so could you show how to change the box color or turn it into a sphere once pressing on it? I won't show in detail how to do that here. Usually if you want, I'll point you in the right direction though. So to change the material of to change the material, you can get, I think in unit.material, you can set material of a unit. So what I could do is simply create here a new material and call it my material. My material, you can give it a red color instead. And in the same way that we called, you remember in the same way we called spawn unit, you can call unit or local position, you can call a unit dot set material and just give it the new material. For changing it to a sphere, what you would do normally is you would turn the cube invisible. So there's a unit.setVisible function somewhere. You would set visible to false, and then you would spawn a sphere on top of it at the same position. So there is you got the local position of your cube. So you could get the local position and spawn a new sphere at the same position that you just got. If you look at the intro to scripting handout, there's a few examples of get and set positions there. Triggering animation by getting close is pretty much the same thing. You're going to get the position of the unit, and you're going to compare it to the position of the camera. So the camera has the same kind of functions. You also, in AppKit, you have a reference to the main camera. So I think it's something that, actually, I won't guess at it. I'm going to go see. In the player script, I'm sure there's an example of how to manage the camera here. Yeah. So see, there's a simple project.camera unit. So you can get the position of this camera unit, compare it to the position of any random unit, so my cube. And then once that becomes smaller, the distance between the two gets smaller than a certain threshold, then you can trigger an animation. You can also do it through flow. In the level update here, you can create a flow node that, once you get to a certain proximity to the object, you'll be able to trigger something. And yes, Dan Matlack has a few of these videos. So there is the webinar that I gave about AR in 3ds Max Interactive. It's actually on the Autodesk University resources. So if you search for Autodesk University 2017, in those classes, there's like HoloLens and 3ds Max Interactive. If you search for that, I'm sure you're going to find it.